This lesson deals with systems of linear equations. A system of linear equations is two or more equations that have the same variables. Here are some examples of systems. They don't have to be in slope-intercept form. They could be, but the ones I'm going to give you are not necessarily in slope-intercept form. 3y equals 2x plus 4. And that can't be a system because we don't have two or more equations, so I have to add at least one more equation. Y plus 8 equals 4x. Now that's two equations that have the same variable. They both have x and y, so that would be a system. Or it could be something like 6a plus 9 equals 2b. Not a system yet because we don't have two equations. 3b plus a equals 12. Now we have a b and a b here, an a here, so that would be a system. Or maybe we even have another equation that has an a and a b in it. So 7a plus 2b equals 18. Negative 18 would be a system. These two together would not be a system because they're not the same variable. So you have to have the same variables in a set of equations to be a system. Many times a system of equations has a solution for, or a value for each of the variables. If it's an x and a y, there would be a certain value for x and y, values for x and y, that would actually fit into both equations or all of the equations that would make the equations true. And it's easy to explain when that's not the case, but we'll come to that in a second. Let's suppose we have two equations, and one could be y equals the opposite of x plus 3. And I'm picking some really easy examples here, and you'll see why in a minute. And then another could be y equals x plus 3. They're very similar to each other. This is the opposite of x, and this is x plus 3. That's a plus sign, not messed up there. So we make an xy chart. We'll change colors here so it shows up a little bit better. And yx. And we'll do an xy chart for the other equation too. So this is the first step. Do an xy chart for both of them. And we like to use 0 to start off with. If x is 0, y is 3. If x is 1, now remember this is going to be the opposite of 1 plus 3, so that gives us 2. And here if x is 2, it would actually be the opposite of 2 plus 3, so that gives us 1. And we'll do the same thing here. If x is 0, y is 3. And that's really significant because we see that in both equations, if x is 0, y is 3. And that means something. And here if x is 1, it would be 1 plus 3 is 4. If x is 2, y would have a value of 5. So we're going to graph both of these now. So when we put them on the graph, we'll do this one first. And we see if y is 0, x is 3. So we'll put that on the graph. If y is 1, we go over 1 up 2 is another point, and over 2 up 1 is another point. Then we'll do the second equation. If x is 0, y is 3. If x is 1, y is 4. If x is 2, y is 5. So we get this line here and here. And it's typical that you label the equations. So this is the one that y equals the opposite of x plus 3. And that makes sense. We can see it has a negative slope. So that negative 1x, which it would be if you put a coefficient in front of it, would be a slope of negative 1. This equation has a slope of positive 1. So it's going uphill. And the place where they intersect, which would be this place right there, gives the values where x and y are the same for both equations, which you saw right here, 0, 3. At 0, 3, we get the same values. So in this equation, if x is 0, y is 3. But also in this equation, if x is 0, y is 3. And that's the only combination of numbers where these coordinates would be a solution for this equation and for this equation. So that would be the solution to the two equations that we started with. It's the common solution for this system. So let's take a look at another example. So the two equations I'd like to use here are y equals 2x plus 2 and y equals 3x plus 1. And we'll point out that these two equations are going to have different y-intercepts. In the last set, they both had 3 as the y-intercept, so we knew 0, 3 was going to be the common solution. That's not going to be such an obvious thing in this one. So we put in 0 for x, y would be 2, but in the second one, if we put in 0 for x, y is 1. So that y-intercept is not going to be placed where these lines cross over. Another thing to point out is that these lines have different slopes. If this equation would happen to say that y equals 2x plus 1, we would end up with a set of parallel lines that would never cross over each other. So if the slope is the same in your equations, there's never going to be a common solution. So the system would not have a solution. But because we see the slope of 2 here and the slope of 3 here, eventually both of these lines would have an upward slope, a positive slope. They will eventually cross over each other. They would not be parallel lines. So we know there will be a solution. And we'll continue to put some values in here. This one, if x is 1, y would be 4. If x is 2, y would be 6. And over here, 0, 1, we've got that already. In this one, if x is 2, y is 7. So they're kind of close, 2, 6, 2, 7. And then if x is 3, y is 10. So I'm going to go ahead and put these on a graph. I'll do the graph of y equals 2x plus 2 first. Go over 0 up 2, over 1 up 4, over 2 up 6. Then I think I'll do this one in blue. Yeah, I got blue there. So over 0 up 1, over 2 up 7, and over 3 up 10. Now this is not the most precise system or way of solving equations, because you're going to see I can't draw a very straight line, and the accuracy of using graphs depends on having, use a yellow on that, your line's pretty straight, so using a ruler is pretty much a necessity when you're doing this. And again, it's so imprecise. I know what the solution is going to be, and if you can see where the lines kind of cross, it's really not supposed to be at this point. It's supposed to be right there at 1, 4. And I deliberately didn't put 1, 4 in a solution in the XY chart for this one. But if I did, you'd see that 1 goes in, 4 comes out. And when you have that, just the XY chart shows you the solution. Because if you ever get, when you put a value in for y, same value in for y, and both have been the same, or a value in for x, like 1 and 1, and the same value for y comes out, that's obviously the solution for that system. But when you draw a picture of it, you see it right there too. So it's kind of nice to see the visual for it, as well as what you see in your XY chart. You get a little bit lucky if it shows up in your XY chart. And so the graph, again, though, is so imprecise that it's hard to interpret sometimes. When we get to, and actually I'm going to go ahead and continue on into lesson 11, because there's a very, very precise way that you can be sure you have found the solution to a system. It's really not too hard to understand. So we're going to take a preview of lesson 11, which is a review lesson anyway, but we're going to go ahead and do that and combine it with this lesson coming up in the next slide. So we're going to work with the same two equations we had in the last slide, that y equals 2x plus 2 and y equals 3x plus 1. And since we know that y can equal either one of these two things, we can simply take this value for y and substitute it right there. So where we see the y written, we're going to put 3x plus 1, which leaves us with 3x plus 1 equals 2x plus 2. So the key word here is substitution. I just substituted this value for y where I had the y in this equation. Now I'm going to try to get x all by itself, which I'm going to subtract 2x from this side and subtract 2x from this side. So over here on the left I get x plus 1 equals 2. Then I'm going to subtract 1 from both sides. It's a very simple way to do things. So x would equal 1. Now if x equals 1, I can put 1 here or here to see what y is when x is 1. So I'm going to take this equation. If y equals 3 and x is 1, just put 3 times 1 plus 1. So x is 1 right here. This was the value for x. So then I'm going to calculate it. This would be 3 plus 1, so y is 4, which means when x is 1, y is 4. So the solution is 1, 4. This would be the value for x, and this is the value for y. And if you go back to the previous slide, by graphing, we saw that these two, the graph for this line and this line, intersect at the points 1, 4. So solving by substitution is a very precise way to figure it out. You don't have to interpret the graph. You don't have to do an XY chart until you find the numbers that combine to give you a common solution. So it's really a great way to solve this problem.